This video demonstrates how to conduct propensity score matching. So now we are going to read the dataset in. Dataset is created in Excel. So we are interested in looking effect of right heart catheterization on patient survival. Okay, and patient survival is defined by these two variables. Especially this is 30 days mortality. And this is a binary indicator for the deaths happen within 30 days. And this is a time variable. Let's read this dataset into EZR. Go to import data and click on the first one because I created the dataset in CSV format. If you have Excel, select this one. And I select this one and then click OK and open. Since this study is observational study, there is no randomization. So let's check whether the baseline variables are. Click on graphs and table. Select the second one to the last. And now we are going to create baseline table. So select right heart catheterization variable, RHC. And then, so this is a variable you want to create baseline table separated by. So now we are going to choose variable we want to examine balance. Categorical variable, select here. So you click on race and then keep pushing shift or control key and then select another one. And then same thing. Here you select continuous variables. This box for variables normally distributed. This box is for variables, not normally distributed. For now, I will just click variables on this box. And then we are going to create the table out to CSV file. And click OK. Here is the table we just created with EZR. As you see, there are imbalance in between the groups. So this is for patient without catheterization. This is for patient with catheterization. And for example, age is differ by just 1 year. But since sample size large and p-value is significant. And this is a severity variable. And now you can see patient treated with catheterization are much severe. Ignoring this baseline imbalance, see what happened. So you go to survival analysis. Let's create Kaplan-Meier table. So time to event variable, and here is a status variable, and here is a grouping variable. And as you see, patients with catheterization have a worse survival than those without. This analysis is biased because there are much severe patients in the group with catheterization. So we are going to conduct propensity score matching now. So propensity score analysis, and you will use logistic regression. And then here you will put exposure variable. And then here you put baseline variable. Let's see. Okay, and go ahead to click make propensity score variable. Okay, and OK. So blue line is a distribution of propensity score among patients with catheterization, and orange is one without catheterization. As you see, the blue one, patient with catheterization's propensity score are a bit higher than those without. Propensity score is actually created on the last column on the data set. And since this data set is too large, we cannot actually view the data set. But if you have a smaller data set, go ahead to check the propensity score variable. Now we go to matched pair analysis, and here extract matched controls. So grouping variable is right heart catheterization. And then matched on propensity score. This is the propensity score we just created. Okay, and then click on yes. Okay, so we want to do 1-to-1 matching. You can actually do 1 to 2 matching or 1 to 3 matching if you have enough number of controls. And click on yes for caliper matching. Caliper is actually create the range patient with and without catheterization are matched if the propensity score are within in this range determined by the caliper. Okay, so if you want to have more precise matching and you want to make it smaller, and then 0.2 is a default. So what 0.2 mean is unit for caliper is a standard deviation of the propensity score. So we allow for matching if the propensity score are within 0.2 standard deviation of propensity score range. Okay, and then click on OK. We have a different name for this data set. This data set contains only the matched data. Okay, and then you go to recreate summary table, and you can actually compute standardized differences on this table. Click on OK. Okay. So what is the standardized mean difference? So here's the difference. For example, the difference between age, mean age is 61 versus 60.6. This is about 0.4 difference, but the difference between albumin is about 0.01 difference, which is larger. We can't compare 0.4 difference in age and 0.01 difference in albumin because the scaling is different. Okay, so in order to have this comparison possible, we need to standardize this difference by the standard deviation. Because if the variables are normally distributed, most variables range mean plus minus 2 standard deviation. So divided by standard deviation, compute standardized mean difference, and so that we can compare the difference among different variables. What do you think? This is a table without matching, and this is the table with matching. By conducting propensity score matching, standard mean difference is much smaller. And now you can conduct the final analysis. Final analysis use the data set with matching and conduct analysis as you would analyze randomized clinical trial data. Okay, so now we use matched data set and conduct the final analysis. So we are going to examine the effect of right heart catheterization on the patient survival. So you go to survival analysis, and we don't have to adjust for confounders baseline imbalance because there is no imbalance. And go to Kaplan-Meier and conduct analysis just as you have randomized clinical trial data. So you still see the difference between the two groups, but the difference is much smaller than analysis without matching. And this is the p-value for the Kaplan-Meier analysis. So what do you think? With EZR, you can conduct propensity score matching. And in fact, the new version of EZR, you can now do inverse propensity score weighting analysis as well. So let's see the next video.